Hello everyone and welcome in this new recording. Today we will be talking about text rendering in the NervLand project. So this is a devlog number 23 and I have already been taking notes on this, and let's just quickly see what we'll be reviewing and discussing today. So the first thing I was doing was trying to use a FreeType to produce a texture like this one, so a font texture if you want. And then I was trying to use this to actually display some text that you could read with my engine in the WebGPU, doing quite a lot of check to try to understand how you position those glyphs and what baseline means, and how you would space your characters and things like that. So we'll try to get a bit more in details with that. Then I have been working on quite important optimization steps to try to render those texts in an efficient way with a WebGPU. So we'll discuss that. And yeah, the idea was to be able to dynamically update the text content without having to rebuild complete WebGPU pipelines, which is an expensive operation. So you don't want to do that at runtime. It's better to do it only once at start on setup. And yeah, with that we could dynamically update the text, and we have introduced support for proper positioning of the text, because at first I was basically forcing the position in the shader program, and then we worked on introducing the concept of projections. And yes, with that you could apply an offset to position the text wherever you want. So we could, for instance, place the text at the center here. And finally, I have also introduced the concept of anchor point, so you could decide that you want to center the text on this target point, or you would move it vertically, centering horizontally, and placing the text under this point. So you have quite a list of different anchor point, and this is it. So let's try to get into the details now. And at the same time, I'm still trying to make this recording not too long, because I tend to make them way too long. So let's see how we can do that. First step is to set up FreeType. So we use the FreeType library to load the font file. And as usual on my side, I'm using, let me just organize that a bit. I'm using the project to build all those dependencies. So in there you will find that there is a builder for FreeType here. Of course I'm trying to build that both on Windows and on Linux, and in both cases, as you can see, you can actually provide quite a lot of dependencies for FreeType. And for my part, I have been providing, I think, most of them, except, as I mentioned here, bzip2, which, as I said, is a pain to build on Windows. I mean, yeah, I could not really find a way to integrate that in the NervProj, so I just gave up. If you are to try to use the output produced by FreeType, at some point you will need to check a bit the documentation and try to read on what those glyphs are, what you can extract from those fonts and so on. So this is, for instance, one of the documentation page, so you probably want to have a look at that. And yeah, in the end, the idea is really that FreeType is allowing you to get small bitmaps for different glyphs, and those glyphs, you get information along with the bitmap itself. Like, okay, I'm providing you this area, but in this area I'm drawing actually a character, and the baseline should be this number of pixels from the top of your bitmap image. The left border is this number of pixels, and things like that. I guess that's the only important things from my perspective. So where did I build this texture actually? Let's try to find that. So here we go. I actually have two different font classes. There's one here in the what I call my GPU module. So it's a WebGPU font, and this one actually contains one of those base font class, and this one is rather defined in my core module, because this one is only the one which is interfacing with a FreeType, so it's not related to GPU rendering yet. So you could consider loading a font for something else, like 2D drawing or whatever, that would not rely on WebGPU. That's why this base class is in the core module here. And the function we are interested in is this one, compute glyph atlas. This one is the one I'm using to start from a FreeType face object, and I think this is where you actually extract all the glyphs one by one, the glyphs that you want to retrieve. So let's see, you have also the consideration of the pixel mode. Usually I think it's something like the gray one, but you could have color fonts. I'm not really handling that so far, I think, but anyway. So preparing a buffer to store all the content, and then that's it. You would iterate on a list of code points. The code points are, I don't know if you could say that, I mean, it's supposed to be an integer value, and this is the code corresponding to any given character, any Unicode character. So you have more code points than just 255. And you use one of those code points to specify, for instance, if you want to display the A character, you're going to use the ASCII code for A, which is 97, I believe. And you would then get a glyph out of this, loaded in this face, and this glyph contain your data for this specific character, as well as the bitmap data itself. So I was then building a big texture, completely black at first, and you need to iterate on all the characters that you want to have available from this font texture, font file, sorry, and you want to draw each of those characters on your font texture. So you need to be a bit clever and pre-compute, okay, what is going to be the size of your texture, so that you can put that many characters on the line, and then you can build some kind of rectangular, I mean square shape texture, but you could also put all of them in a single line, I guess, but then it's less convenient if you want to debug the display. So yes, it's a bit tricky. It's a pretty large function here, but in the end you collect all the data you want, and you are at the same time filling this buffer that you would then use to create a texture. So this, I guess, is where we do the actual filling, the actual copy of the source data into the destination buffer. And after that, when you are on the WebGPU side, at some point you can get a texture for this FreeType font file, and you would call this produce some data, which is going to be stored in this, and then you decide, okay, I want to prepare a 2D texture, and you keep track of this texture, And then more stuff going on for that, but we'll come back to this. And after that, sorry, I think I have simply come on, too many stuff here. Text drawing. So this is the usual setup of my application, and there is the first element here, which is to draw the skybox, and the second one, yep, that's the one. It's a simple texture model drawing, and I'm using the font texture to display this font texture. So if we were to disable everything else, it should still work. Which one is it? Build. Okay, it's built. So now I think it was mentioned just before. So this is texture that I have been generating. Okay, next step. Yeah, then I was trying to display some actual text using this font. And that's where I introduced the text renderer concept. So this one is another pretty large one. And it has been changing a lot already. So what can I say about that? At first, yes, I was trying to use this class, text class. So I was thinking I would have a text class with some text content and also linking this text class to a specific font and then give it a position, color, and so on. And then I would use this and assign it in the text renderer, because the idea was to have the renderer produce only a single render node with a single pipeline in there and draw multiple texts with a single pipeline. But quickly I realized that I don't really need to have a dedicated class for the text. We could rather just embed the concept of a text slot, if you want, directly in this text renderer class. So this is what we're doing now. When we create a text slot, we provide some text information, and we're going to eventually store that with a text description inside the class. But then you are actually going to keep separated list of text per font, because this is the key thing actually when it comes to rendering. For each font, you need to have a draw call using the corresponding font texture. You could push it even further and provide a texture array, I guess, and then you could just use a single draw call for all your fonts together. But for now, I thought I would keep it a little bit more simple, and yes, you still need separated draw call for each font. So it means that for any given font, you can add as many text slots as you want using this font. It's not really as many because I have a limit of size for the buffers, but you can configure that anyway. And so when you add a new text, you are going to first prepare a font context for the font you have been requesting if it's not created yet, and your text description is going to be stored in this font context. So let's see where this is done. If you have the add text, for instance, here, so you first get or create the font context for the requested font, and then you just push the text element. And at this point, you don't really do anything more than that. Because it's only when it comes to preparing the render bundle that you need to actually collect all the font context and then all the text slot and prepare the render node and the render bundle. What I really focusing on here. At first, I was really just experimenting, I guess, with how you would draw all this, because I remember I was at the very beginning in the constructor itself, adding the draw call for the render node, and just playing a lot in the text rendering shader. So you see high up in fixing some information like this one where I fix the position of the text. So the idea in this shader is you provide the font texture and a simpler, and you provide a storage containing your glyph information. So you would specify for each character that you want to draw, okay, this character is for the glyph A, which is located in this small rectangle on your input font texture. So you're going to provide the coordinates of this small rectangle in the font texture as in a storage buffer. And then for each you're going to make a draw call which is going to be 6 times larger than the number of characters you want to draw, because for each character you need to draw 6 vertices to be able to display 2 triangles, so a small quad. And you would then use the vertex index in the shader itself. So you have the input here, and the instance index, because the way I do it actually is I'm just making a draw call with 6 vertices, and I'm using the number of instances to, I mean, that could be something I could optimize. I'm not quite sure about that, but I think there's a slight additional cost when you use instances. But yeah, the way it is currently, you have 6 vertices for the number of instances, which is the number of characters that you want to draw. So I increase this instance number depending on the number of characters. So you figure out, okay, what is the index of the character you want to draw. This is actually giving you access to this the glyph that you want to draw. And with this glyph, you have the information concerning the location in the source font texture. What I eventually introduce also is the information concerning the destination on screen. But first, this was a bit more fuzzy, and I was rather providing like just the baseline position and the offset from the left, and I was progressively building my characters this way. Anyway, I don't have much time to go into too much details here, I guess. This shader is pretty complex if you think about it like that. But it was a lot of trial and failure and more experiment, but eventually I could get all the characters to display and to be aligned on the baseline, which is the key thing when you want to display a line of characters, because you can easily get them completely messed up vertically. So you need to refocus on aligning everything on the baseline. Alright, what else should I mention on this part? Yeah, I had a small test at first where I would also display this border for the characters to figure out, okay, what is the source glyph actually providing me. So you see, it's not always the same size depending on the character. And to display that, I think in the shader at some point I was using this UV2, yes, and when I was computing the coordinates, I mean, it's still the case, I'm also computing UV2, and eventually I'm providing that to the shader, which means that it should still be working here if I just enable that and draw the yeah, I actually disabled everything, sorry about that. Let's just re-enable it. Okay, I re-enabled the text rendering, and you see here the border for each character, which is not that easy to read. Sorry. Anyway, let's not keep this one. It was really just for investigation at first. So what else do we need? Yes, when working on that, I actually got to realize that if you think about it, storage buffers are pretty much just like the uniform buffers in WebGPU. I mean, it's just the name that is changing and the way you use it in the end. So just the usage basically, but you would have to update them the same way, just considering that both are buffers, and you would then assign them the same way in your render pipeline. So again, you can keep the concept a bit more generic that what I was thinking at first. So at first I had a UBO provider for uniform buffer object provider, but I have been renaming this class to simply buffer provider because it can be used to update any kind of buffer, either uniform buffers or storage buffers. And in this case, actually, what we're going to update are the storage buffers. So yeah, I have refactored that a little bit. Then what else? Yeah, this was a small additional step to create a camera. I now have a dedicated create camera function, and I use the same kind of concept to create a text renderer now. I can provide a name. This is a string operator, so it's converting this text into a number, an ID, and you would get a text renderer out of this, and then I can just add a text. It's funny, why do I have characters? Okay, anyway, so yes, this add text, so we're calling that, so here we create a text and then we call add text, and I was just really providing the position, the text itself, not really the additional details here. And after that I was preparing a bundle in the render pass. These are only two simple lines drawing, and yeah, then you would draw your render pass. And at first this was kind of a static text. You could not really modify that anymore, because when you're modifying the text, you also have to modify the number of characters that you want to draw, and this number of characters is what you use to make your draw call. So you have to draw that many vertices because you have that many characters to display. So if you were to draw a text with a different size, actually you would need to change that, which means you would need to rebuild your render pass, because you would need to change the render bundle here. Well, you will need to rebuild the render path. Yes, I think so. But you need to rebuild the render bundle at least. So the way around that is you can use what is called an indirect draw call. So the idea with indirect draw calls is that the information concerning the number of vertices, number of instances, and yeah, also the first index and the first vertex and the first instance that you want to draw, all this information is not going to be provided directly to the draw call. It's rather going to be specified in an additional buffer, which is used as an indirect source of information to perform the dual call. So then you just need to build your pipeline with an indirect dual call targeting a specific buffer, and that's it. You don't need to update this pipeline anymore. Then whenever the number of character is changing, what you do is you update the content of the buffer. So you increase or decrease the number of vertices in the buffer. So you just send a write command to the buffer, but your bundle, your render paths, all this is fixed, is not changing anymore. So this is what I have been working on then. And so if you go, where do we do that? It's basically when we prepare the render node. So there is a function called construct render node. When you do construct the render node, you create a render node if it doesn't exist yet. And if it already existing, actually you can't really add more text slot. And you would then iterate on all the font context. And for each of those font contexts, you're going to provide an indirect dual call targeting a given buffer. That's a WebGPU buffer. And in case you would have multiple fonts, you could actually still add multiple indirect dual calls here, one per font. And that's where I would do the binding, where I assigned the corresponding font. And this is it. Then all you need to do is, when you have an update of your text, you need to update the content of this buffer here. So this is done. So that's how you create it first. And this is done, yes, in the update buffers, which is the main function called, because this object is a buffer provider. So whenever the engine is going to request the update of all the buffer providers, this would be called. And you would figure out, okay, there was some change in one of the font context because some of the text was updated. And in this case, you need to update the content of your buffer here and send a write command. And yeah, with this change, I could then start updating the content of the text dynamically with this call here. And I think we have a small animation for this one. Indirect dual call, yes. Where is the small animation? Okay, it's after that. I mean, this is still the same part, right? Well, at first I was just introducing indirect dual call, but not really updating dynamically yet. But yes, this is what I'm doing now. And yeah, you can get the update of the text dynamic. All right, final touches, and that's the text position on screen. That's at this point, that's where I introduce the concept of the projection. So you could actually, well, position your text properly, assuming that you have a given screen size. You could say, for instance, that you have a 1080p screen display, and so this gives you a number of pixel width and height, and you can just use that to provide a position. So this is what we're doing now with the position element here. So when you provide that to the text slot, it's going to be stored in the text here with the position, and then whenever it's time to update the content of your text, you would compute all the glyph position and all, and at some point, so you can figure out what is the size of your text, and at some point, yes, you get the position of your text, and you would apply that as an offset for all the glyphs. So here, when you have the position of the glyph, you get the text position offset, so you get this position properly on screen. And yeah, we already taking too long, so let's go faster. So at first I was at the bottom left corner here, but if you specify that you want to go at the center like we're doing here, then you will get the bottom left corner of the text in the center of the screen. And after that, yeah, I had some minor consideration because I got some NaN values, but let's not mention that. At first, yeah, this was only for the support of the positioning, but I was not really using the position parameter. But starting from here, that's what I did, producing this parameter. And then the final thing I need to mention is really this anchor point, which again is actually connected to the text position, because once you have the bottom left corner of your text rectangle here position where you want, and you also know what are the vertical and horizontal dimensions for this text, because you have already been computing that, so you know the number of pixels that this should take, then you can easily apply an offset to your text position to get the center of the text, for instance, here position where you want. So I have just been introducing different anchor point like that, and all what we do is in the text render, I think it's this one, this big visible thing, you compute an offset depending of the text anchor, and you will add this offset to the text position just here before again using this position to offset each of the glyph location. And yes, with that you can specify the anchor as part of the text description here, and you get that position properly just as expected. All right, 32 minutes. I think we're going to stop here. There's much more I need to do on this text mechanism. Next thing, for instance, would be to add support for color management. So you could specify the color you want for each of the text slot. I have even not tried to display 2 text slots, so that's probably going to break, so we'll see. And yeah, there's much more to keep adding on this, so we'll continue in another session. But for this one, this was an initial overview, and I think it's pretty long already. So thanks for watching, and happy coding, and see you next time. Bye bye.